Okay, this is problem number 2, the Ferris wheel problem. There's a Ferris wheel every year at the North Georgia Fair. This year the wheel has a radius of 33.2 feet and makes a complete revolution every 15 seconds. For clearance, the bottom of the Ferris wheel is 4 feet above the ground. So let's go through and work this one out. We know our minimum value is 4 feet, so I'm going to mark this off as 4 feet. I'll do that with a broken line. So this is the x-axis. This will be the y-axis here. This is y. Now, to find the maximum height here, I've got 4 feet, and then we have a radius here of 33.2 feet, so plus 33.2, but that's a radius, so I have to double that to get the diameter. So my maximum height is going to be 70.4. Let's call this 70.4. So I'm going to indicate the max with the broken line also. Now let's find the amplitude. The amplitude is going to be the high 70.4 minus 4 divided by 2. So that will be 33.2. So amplitude is 33.2. The vertical shift is the high plus the low divided by 2. So that will be 37.2. That's going to be D, 37.2. So I'm going to call this D here, 37.2. And I will draw a broken line here. Now this becomes my new x-axis because I've shifted the x-axis up 37.2 units, so this is x prime. Okay, now let's see what other information we have here. We're told that we have a complete revolution every 15 seconds with 4 feet off the ground. So when we start, we're going to be down here. And then every 15 seconds, let's call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to be back at this point 15 seconds later. Well, halfway in between, since it's sinusoidal, we're going to be at the very top. So halfway between 0 and 15 is 7.5. So at 7.5, we're going to be up here. That means our period is 15. So B is going to be 2 pi divided by 15. Oh, you got that. Now since we're starting here, we did not move the y-axis over any at all, so there is no phase shift. That's just 0. And we can sketch this graph now. And this should be a curve, no straight lines on a sinusoidal graph. Okay, now that's kind of weak looking, but it does serve the purpose there. Now let's find a key point. 0, we're going to be at 4. At 7.5, we're going to be at 70.4. Now let's look at our graph. This is the origin here. This is our new adjusted origin. It moves. So you can see we're starting below. If we'd started at this new origin, it would be a sine function. So this has to be a cosine. Since it isn't up here, it isn't a positive cosine. It's down here, so it's a negative cosine. So we're going to use this one. Now let's write the equation. That has to have a y in it. So this is going to be negative 33.2 cosine of 2 pi over 15, that's our b, x minus c, which is 0, plus d, which is 37.2. So let's adjust our window. Our y value has to go from 4 to 70.4, so let's look at the window. Let's do the y first. So we'll go from, let's say, 2 to 72. The x value, we have a question which asks where we are in 52 seconds, so we're going to have to go from 0. I don't want that, so let's clear that up. Y min was 2, y max we're going to put in at 72. The x min is going to be 0, and the x max is we're going to have to compute a value at 52. Let's make it 55. Let's plug in our equation. Negative 33.2 cosine of 2 pi divided by 15 x minus 0 plus 37.2. And let's graph it. Well, that's our graph there, it looks like. So let's check and see if our critical points are matching up. Second trace, 1. We put in 0. We got 4, so we're good on that. And let's put in 7.5 and see if we get 70.4. And we did. So the critical points check. Looks like this is a good graph. Now the question was, how far above the ground is the passenger 52 seconds into the ride? So let's put in 52. And we see the passenger is 69.67 feet above the ground. Okay, that's problem 2, so we'll stop there.